After a long break, here he is again. Unfortunately, I had a short stay in hospital and had to take things a bit easier, hence the long break. Yes, today. About half a year ago, I made a short video about Wi-Fi reception on the D1 Mini, how you can modify it, how to get better reception. And today, I'm doing the same thing again for its successor, the ESP32C3 Super Mini. It's a bit shorter because I didn't want to do everything twice, but definitely easier than with the D1 Mini. Let's get started. Months ago, I'd already made a video before and had a go at a modification for the Wi-Fi reception and showed you that as well. And now I'm doing the same thing again for the especially 32C3 Super Mini. So in this video, I'll simply show you how you can improve the Wi-Fi reception on the little C3 Super Mini with some relatively straightforward modifications. It's fairly easy, although you will need to do a bit of soldering, but it's definitely easier than with the D1 Mini. Yes, as I said, the new generation, the ESP32. C3 Super Mini is noticeably better. Compared to the classic D1 Mini, it also has Bluetooth LE. LE stands for low energy, so that works quite well too. I don't use it as often, but it's definitely included in the package. You can also configure the I/O areas quite flexibly. And that means you can control the displays better as well. There's simply more freedom. I don't really want to say much more about the especially 32C3 Super Mini. Right, Wi-Fi signal. As I mentioned in the last video, this is all a bit experimental. You can't really take the length specifications too literally. You really have to experiment a bit and gradually work your way towards the best result. The PCB antenna on the small ESP32, according to the specifications, only provides a maximum of 2 decibels. So that basically means it only has range within a single room. I've installed a little Wi-Fi checker as an INO file on each small ESP32C3 to measure the Wi-Fi signal. You'll see that in a moment. To show the measurement properly, you can simply download the INO file from my website. You don't necessarily have to use this checker. It also works with Tasmota or Home Assistant. You can actually read the signal strength there as well. I just think this way is a bit more accurate. Yes, bricks. With the whole thing, you actually get a 3 decibels gain. A 3 decibels gain means a doubling of the transmission and reception power. So it definitely works, as the RSSI signal is better than minus 70 dB. It works, I've already said it, 3R. And yes, the question that usually comes up now is whether a repeater isn't actually the better option. If it can be avoided, I try not to do that either, because radio communication these days is already congested enough. The frequency band is very narrow. So I think to myself, let's just try to sort things out with a bit better reception and transmission power. Theory and practice: simply determine the channel, identify the frequency, and work out the wavelength online using a calculator or Google. And then just stick to the lambda-half or lambda-quarter reference values. That's the theory, but I've already worked it out for you. The Wi-Fi frequency at 2.4 to 2.5 gigahertz. That's a wavelength of 12.1 centimeters to 12.4 centimeters. The rule of thumb is half the wavelength, around 6.2 centimeters, and always a whole number multiple. Since we're making quarter rods, that's lambda quarter. These are the test subjects on the left. The especially 32C3 Super Mini, and on the right is the Super Mini Pro, which has an external antenna. I'll come back to that briefly at the end. You'll need to do a bit of SMD soldering again, but the test I carried out wasn't anything special really. So, to be honest, you could save yourself the bother. It cost €2 or €3 more. It wasn't the success I'd hoped for, to be honest. This is my test setup. Up here, I've wired it up at the back. This is a displayed. Up here, I'll clamp in the little ESP32s. This is where the INO file is loaded, the WLAN checker INO. And so I practically always have the same conditions. I've set up an AP, an access point, in the same spot, so the conditions are always basically the same. Yes, that's my quick pre-assembly guide, just before we get started. So I took 75 amp antenna cable, stripped it, then assembled these little rods, and when you test them, you basically use a pair of side cutters. You snip off a little bit at a time, millimetre by millimetre, until it fits. That's the length, like I said, 32 millimetres. Roughly, you should use 32, 31 millimetres and then build the entire antenna from that. That turned out to be the best way, because it gave the best results. Just a touch again on the SP32 Super Mini Pro. That's basically with the plug, so to speak. Yeah, you can basically attach an external antenna here, but you do need to solder it. I'm not sure, I might make it a bit bigger on the website. It's quite fiddly, and that's why I wrote down, don't forget the solder bridge. And in my opinion, the result wasn't really as I'd imagined it would be. But everyone should decide that for themselves. Right, now I'll demonstrate how I measured everything. I'll start with a reference measurement from a completely standard ESP32C3 Super Mini, and then we'll go through one by one everything I've added on. Terms and modifications. You can't quite see it properly now. Like this. The reference value. Reference value of 77 and 34%. Let's write that down again now. 77 and 34%. Right, let's see what can be improved. So I'll just show you a few little experiments, how I did it, how I got to the point where I found the right thing, which I'll show you at the end as well. That was one thing I tried. I saw it online too. It's basically a quarter wavelength. You can see it up there. I attached it to the side, but it didn't really make any significant difference. Those were the preparations I made to start with. It's always half wavelength and quarter wavelength, so 64 millimetres or 32 millimetres. And this is actually a coaxial cable. I just stripped it so you have something a bit more solid. That's what it all looks like. I think you can see it here like this. That's how it's been. And that's where I tried out the different things. In the end, it always comes down to making one a bit longer. Attaching a little tree to it and then trimming it down millimetre by millimetre until you found what works best. So it really is a bit of fiddly millimetre work, but once you've figured it out, I think it's actually dead easy. All right. I've now attached 64 millimetres to it. That was always one of my tests as well. And now I'm going to trim it down a bit and you just watch the results. We're already out of the range again, and now we're coming into the quarter. If I go further down here now, you see, now we're getting there automatically. That's how you can try it out. Can you see that? If I approach it a bit more carefully now it really comes down to millimetres. You just have to work your way towards it bit by bit. Now, I think just a tiny bit more. That was my first attempt. Right, let's see where that gets us. And these are the sorts of experiments you just have to try out a bit. That's just how it is, unfortunately. But in the end, I found something even better. You go further down now, then it disappears again. Then you're already out of the range again. Although it's still noticeably better, even better than the reference. But if I go even further down now, I don't think it'll make much difference anymore. Well, actually, it does. You always have to bear in mind 3 decibels. That's double the power, so double the reception. That's just with those little steps. Hopefully I'll trim this down a bit, otherwise it'll get too boring. Now I'm going even further down, and then it'll disappear. Actually, that wasn't too bad at all. Alright, I don't want to go on with this. So, system problem understood, that's how you do it. So we've really gone down quite a bit now. What was the reference again? I have to check again. What do we have there? At 77 dB and 34. Now with these little stubs, we're at 67 dB and 55. So it does make quite a difference. Right. That's ultimately the result I got, which really works best. It's similar to this one here, about 32 millimeters. I only did that so the form factor would be a bit better, so it doesn't stick out over the circuit board here. But these are actually results you can be proud of. You always have to compare it to the reference. I'll show you, so you can perhaps see it a bit better. This is how I soldered it. And that actually produced the best results. It basically works like this. You take a little rod like this, make a little loop at the bottom. Altogether, it needs to be 32 millimeters. And then you attach the little cheat antenna on top. What didn't work, and what I also found online, was a little spiral antenna like this. That really didn't work at all. So what I wanted to do over here was use a little spiral antenna to make the form factor smaller. None of that worked. By the way, this solution here is also explained quite well online. As it is now, in my opinion, it's the best solution you can currently try out to slightly increase the transmission or reception performance. And those are already significant values when you compare them to the reference device, that is, with the standard antenna. Right, I'll now show you the programming, my programming, how I did it and how I measured it. And then I think we shouldn't dwell on this any longer, because I've already shown how it works in another video. And there's no need to go over all the theory twice. You can always have another look at it. There are 2 fantastic websites online, which I'll link again. It's explained very well there. But it's not just about the C3, it's generally about how you can improve Wi-Fi a bit. As I said, for anyone who's interested, I found it very interesting. And in terms of size, it's easy enough to manage. In my opinion, it's easier than with the D1 Minig. Alright. I'll just quickly show my little program again here. For anyone who wants to use this themselves, I'll publish it on the home page for copying. You basically just copy the entire frame. Get out of there. Otherwise, please do it beforehand. Adjust the board. Please go to the Especially 32 board here, then go here and set Especially C3 here. Dev module. The board is now configured. Otherwise, I have practically everything I need here. You copy and paste that. Please change this, I've written it here, the Wi-Fi SSID and the password. Please enter them here. And if you get any error messages anywhere, somewhere up here, then some driver or library is missing. If you can't find it here, just do a quick Google search for the term that's missing. And then it usually finds the right file or the appropriate library, which you simply add in up here. That's not a problem. I don't want to spend too much time on it now because it worked. That's not really the point. And anyway, to upload, you press this. Then you just go to the back. And then you enter it there. I'd already set the other one, ESP332C3. Then this comes up. Then it opens up here. USB board, then OK. And that's it, really. If everything's set up properly and there are no more error messages here, just click on Upload. And that's all there is to it. Right, and that's it for the modification. So this video was really just a supplement to the video about the D1 Mini, which I made about 6 months ago, as I believe the especially 32C3 Super Mini is one of its many successors. It's a board with which you can do pretty much anything. So as I said, the topic was exclusively modification. It wasn't about the especially directly. Yes, conclusion. With a little piece of wire, or the so-called stub antenna, 32mm, as mentioned, you can achieve significant improvements. With Tasmota, under information, level or telemetry, and if you set the period to 10 beforehand, you can do this as well. So you don't necessarily have to use the INO file or the program I showed there. Otherwise, to sum up, the best solution, as you may have seen a bit, and as you'll also find on the internet, is the quarter wavelength wire. So, I'm glad you stuck with it for so long. I went through it a bit quicker, and only took a short break for health reasons. Had fun, and I hope we'll see each other again soon. See you soon, and enjoy a few more sunny days.